In this video, we're going to be looking at Chapter 3, Probability. And here are our topics for this chapter. We're going to start by looking at some vocabulary and look at different types of events, 2 rules of probability, contingency tables, and just a little bit on tree and Venn diagrams. Here's everything you should be able to do by the end of this chapter. All right, so terminology, and this is some work that we've also worked on in Algebra 2, so hopefully it's familiar for you. So whenever we're talking about probability, we always need to talk about the event that we're doing or the experiment, and that's something like flipping a coin, rolling a die, projecting the weather. Whatever it is that it's involving probabilities and chances, it's called an experiment. So if the result is not predetermined, then the experiment is said to be a chance experiment. And chance is the chance of something happening, but it's the probability of something happening. And so we're going to have the probability for success, the probability for failure inside of all these calculations. So flipping one fair coin twice, that's an example of an experiment. So the result of the experiment, that's just called the outcome. And the sample space of an experiment is the set of all the possible outcomes. So if we roll a die, a 6-sided die, the sample space would be 1, 2, 3, 4, 5, 6. Flipping a coin, the sample space would be heads or tails. Okay. So if we have an event that's a combination of outcomes, we're going to be using letters like A and B to represent the events. So down here we have event A. The probability, and event A is getting at most 1 head. So the probability of an event, to write probability, we're going to use a capital P with the event after it. So we put in parentheses what we want to happen. So P parentheses A, that stands for the probability of A happening. And the probability of an outcome is the long-term relative frequency of that outcome. So we're going to kind of get into more about what that means, but basically the probability of an outcome is what happens in the long run. If you flip a coin 1,000,000 times, it's probably going to be pretty close to 50% heads, 50% tails. But if you only do it 5 times, there's no way that would even be 50-50, because the closest it could be was like 2 heads, 3 tails. And so probabilities are, as we've talked about in Algebra 2, they're between 0 and 1, including the ends. So a probability of 0 means something's never going to happen. Probability of 1 means it always happens. Then everything in the middle is where we're going to be working. So 0.5 would be 50% chance. Okay. So equally likely is something that's pretty common sense. It just means everything is an equal chance to occur. So best example would be rolling a fair 6-sided die. Fair just means it's not, weighted, which there are almost no weighted dice, but you can buy them. So it's a fair 6-sided die. So 1, 2, 3, 4, 5, 6. Each one has a 1 in 6 chance of happening, or tossing a fair coin, heads or tails, 50-50 chance. So if you randomly guess on a true-false question on an exam, you're equally likely. Okay, so those are all equally likely. To calculate the probability of an event A when all the outcomes in the sample space are equally likely. So here we go. Here's how we calculate our first probability. What you do is you count the number of outcomes for event A. So we count all the ways we can have success and divide by the total number of outcomes in the sample space. So for example, if we toss a fair dime and a fair nickel, the sample space is 4. There's 4 different ways to do it. It could go heads, heads, tails, heads, heads, tails, tails, tails. So we have 4 outcomes, and we want to find A is getting 1 head exactly. And so the probability of event A, there's 2 ways to do it: the tails, heads, or the heads, tails. So therefore, there are two outcomes that meet this condition. So 2 ways to have success out of 4 total ways to do this. So 2 out of 4, we get 0.5 for this example. The law of large numbers states that as the number of repetitions of an experiment is increased, the relative frequency obtained in the experiment tends to become closer and closer to the theoretical probability. So relative frequency is keeping track of all of our data as we're collecting, as we're running an experiment. Theoretical probability is what should happen. So as back to my coin flipping example, if we flip a coin 10 times, we might get 4 heads, 6 tails, but if we flip a coin 1,000,000 times, it's going to take us a lot closer. In fact, maybe I'll pause this and show that. All right, so we're back and I have a simulator here. So we can flip a coin 5 times and, I want to clear my results. So if we flip a coin 5 times, we will get our results here on the bottom. We could add in maybe 10 more. And we can see our results. Oh, pretty unlucky there. 10 more. Oh, we're getting closer. And what we're doing is looking at these ratios and seeing how they're changing. And so as we add in more, I'll start going by 100 batch. I'll go by a batch of 100. Okay, and so as I do more and more of these, we can see how these ratios get closer and closer to 50-50. Oh, a little bit off there. I'm going to go by, I'll do 1,000 now. Okay, the 1,000 really brought us in. I'll just keep on doing a few thousands. Let's see if this 0.4946 gets closer to 0.5. Oh, there it is. It's growing a little bit. Oh, wow. Whoa, that was really close. Oh, back off a little bit. And so you can see as this will continue, it's going to get closer and closer to 0.4999 and 0.5000. And there we go. That's the law of large numbers telling us the more of these trials we do, the closer and closer we're going to get to the actual probability of 0.5. All right, so if I go back, that is the law of large numbers. So our next is going to be talking about or and that it means just exactly what it means, I suppose. Or just means if we say A or B, that means event A or event B can happen. It doesn't need to be both. But if we say and does mean both. That means A and B both need to happen. So here we have some examples with numbers. A is 1, 2, 3, 4, 5. B is 4, 5, 6, 7, 8. So to write out A or B, we just write out everything that's in A or in B. So 1, 2, 3, 4, 5. And we pick up on, let's see, 4 and 5 are shared in both. Notice we don't write those both times. And then we write 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 are A or B. The end event is just everything that occurs in both A and B. So A is 1, 2, 3, 4, 5, and B is 4, 5, 6, 7, 8. So the only thing that's in both is 4 and 5. So there's the and part. So that's the difference. That's the difference between and or. All right, the complement is next. And the complement just stands for the opposite of. And the opposite of A is denoted with A prime. And it consists of all the outcomes that are not in A. So, what would be a good example of this? The probability, maybe we're looking at weather. Event A is the probability it rains today or snows. Not A would just be the probability it doesn't snow. And those two outcomes, it's either going to snow or not snow. And so those probabilities need to add to 1. And that's what they're explaining here. So here, let S be 1, 2, 3, 4, 5, 6. A, 1, 2, 3, 4. So the probability of A occurring would be this. So the probability of not A, or just if we list not A, would be 5 and 6. It's everything that's outside of this, but still in our sample space. So the probability of A would be all of our favorable outcomes, 4 out of 6. The probability of not A would be 2 out of 6, just these two, 5 and 6. And we can here see the probability of A and probability of not A would be 4, 6, and 2, 6, which adds to 1. I will stop this video and we'll pick up on that next.